Today's lesson is on rational exponents and properties of exponents. What is a rational number? A rational number is a number that can be written as a fraction of two integers. And so a rational exponent then is an exponent that is a fraction. For instance, a to the m over n power. Now, as you may recall, the number on the top is the power. The number on the bottom of the fraction is the root. And so a to the m over n means the nth root of a to the m power. It can also be considered the nth root of a to the m power. We can take the root first, or we can take the power first. What do you think is easier generally to do first? Generally, it's easier to take the root first because we're dealing with a smaller number. Now, consider the expression 7 to the 3/5 power. Rewrite this expression in radical form. The number on the top is the power, the number on the bottom is the root, so 7 to the 3/5 in radical form would be the fifth root of 7 to the third power. Or we could write the fifth root of 7 to the third. Consider the radical expression, the sixth root of 9 to the fifth power. Rewrite this expression in exponential form. In exponential form, this would be 9 to the 5/6 power. Now, sometimes we can evaluate an expression. We can find out what it's equal to. 8 to the 2/3 means the cube root of 8 squared. The cube root of 8 is 2, because 2 to the third power is 8. And 2 squared is 4. Now, we said we could take the power first. If we took the power first, this would be the cube root of 8 squared, which would be the cube root of 64. And what to the third power equals 64? Again, that's 4. So either way we do this, 8 to the 2/3 is equal to 4. Now, evaluate this expression. What is 9 to the 1/2 power? The number on the bottom is the root, so that would be the square root of 9 to the first power. And we don't need to write to the first power, so the square root of 9 is 3. Now, evaluate this expression. Pause this presentation, calculate the value of 81 to the 3/4, and then restart to see if you did this correctly. The fourth root of 81 is 3, and 3 to the third power is 27. So 81 to the 3/4 is 27. Evaluate this expression. Pause the video, figure out the value, and then resume. 32 to the 2/5 power, the fifth root of 32 is 2, and 2 squared is 4. Now, we want to be able to solve equations with rational exponents. So if we're given the equation 3 to the x over 2 times 3 to the x over 3 equals 3 to the 9th, we want to solve for x. Now, we know that when we multiply numbers with the same base, we add the exponents. So on the left, we have 3 to the x over 2 plus x over 3. Now, when we add fractions, we want to find a common denominator, which in this case would be 6. So we have 3 to the 3x over 6 plus 2x over 6 equals 3 to the 9th. Now that we have a common denominator, we can add the fractions. So we have 3 to the 5x over 6 equals 3 to the 9th. Since the bases are the same, they're both 3, and the expressions are equal, then the exponents have to be equal. So 5x over 6 equals 9. And now we can multiply by the reciprocal, 6 over 5, and so we get x equals 54 over 5. Try this one. 2 to the x over 4 times 2 to the x over 6 equals 2 to the third. Pause the presentation, calculate the value of x, and then resume. The answer is x equals 36 over 5. Now, what if the bases aren't the same initially? 27 to the x minus 4 equals 3 to the 2x minus 6. What we want to do is rewrite one or both expressions with a common base. For 27 and 3, what would be the common base? The common base would be 3, because I can take 3 to a power to get 27. 3 to the third power is 27. Now, when you take a power to a power, we multiply the exponents. So we multiply 3 times x minus 4. So now we have 3 to the 3x minus 12 equals 3 to the 2x minus 6. Since the bases are the same and the expressions are equal, we set the exponents equal to each other. Then we can subtract 2x from both sides, add 12 to both sides, and we get x equals 6. Now, for this equation, 1 over 125 to the negative x over 2 equals 1 over 25 to the negative x over 3 minus 2. We have two expressions. We want to find a common base, something that I can take to a power and get both terms. Now, for 125 and 25, what is the common base? The common base is 5. I can't take 25 to a power and get 125, but I can take 5 to a power and get both terms. However, these are in a fraction, so how do I get the reciprocal? Well, to get the reciprocal, we need a negative exponent. So 1 over 125 would be 5 to the negative 3, and 1 over 25 would be 5 to the negative 2. And now we can take a power to a power, so we multiply the exponents, and we get 5 to the 3x over 2 equals 5 to the 2x over 3 plus 4, because you had to remember to distribute the negative 2 to both terms. Now, since the bases are the same and the expressions are equal, we set the exponents equal to each other. And now we have fractions. We want to find a common denominator, which would be 6. So we multiply every term by 6, and we get 9x equals 4x plus 24. So subtract the 4x, divide by 5, and we get x equals 24 over 5, or 4.8. Now, try this one on your own. Pause the video, calculate the value of x, and then resume. You could have used 2 as a common base. You could have also used 4 as a common base. 4 to the 4th power is 256. So the solution you should have gotten is x equals 1. Try this expression, this equation. 1 over 8 to the x over 2 minus 1 equals 1 over 4 to the x over 3. Pause the presentation, find the solution, and then resume. 1 over 8 would be 2 to the negative 3. 1 over 4 would be 2 to the negative 2. And solving all the way through, we would get x equals 18 over 5, or 3.6. Now, in this picture, we have 3 square blankets and a rectangular area. 3 square blankets are set up as shown in this picture. What is the area of blanket C? Well, in the rectangular area that has an area of 12 square yards, we know for a rectangle that area is the length times the width. For blanket B, the area is 8 square yards, so the blanket's side the side length of blanket C has to be the the square root of 8. The square root of 8 can be written as 8 to the 1/2 power. And blanket C, the side length would be the square root of x, or x to the 1/2 power. So the side length, 8 to the 1/2 times x to the 1/2, has to equal the area, 12. Since both terms have the same exponent, we can combine them with the same exponent. So 12 equals 8x to the 1/2 power. To get rid of the exponent, we need to take it to a power to make it equal to 1. So we take it to the reciprocal, which is 2, which makes sense. If 1/2 is square root, then we're squaring to get rid of square root. So we square both sides. Squaring 12 gives us 144, and squaring something to the 1/2 power gets rid of the 1/2, so we're left with 8x. Divide by 8, we get x equals 18. The question was, what's the area? So the area of blanket C is 18 square yards. When the side length of blanket A is multiplied by 2 to the 1/2 power, the result is 6 yards. Find the area of blanket A. Pause the presentation, see if you can find the solution, and then resume the presentation. The answer, we would take x times 2 to the 1/2 equals 6. So x equals 6 divided by 2 to the 1/2. And so that's the side length. So the area is 6 over 2 to the 1/2 squared, which is 36 over 2, which is 18. So the area is 18 square yards. Now we have two terrariums. The volume of terrarium A is 2 to the x cubic meters. The volume of terrarium B is 2 cubic meters. Terrarium A and terrarium B are cubes. The side length of terrarium A is twice the side length of terrarium B. So what is the value of x? Well, since the volume is 2 to the x power, then the side length would be the cube root of 2 to the x. And we can write the cube root as to the 1/3 power. And so the side length of terrarium A is the cube root of 2 to the x, or 2 to the x to the 1/3 power. With terrarium B, the side length of terrarium B is the cube root of 2, or 2 to the 1/3 power. Now the question said the side length of A is twice the side length of B. So we could write a proportion of A to B. That proportion has to equal 2. Now in the equation, 2 to the x to the 1/3, we take a power to a power, we multiply the exponents. So 2 to the x over 3 over 2 to the 1/3 equals 2. When we divide numbers with the same base, we subtract the exponents. So 2 to the x over 3 minus 1 over 3 equals 2. Since the numbers are the same, the exponents can be set equal to each other, and 2 has an exponent of 1. So now we set the exponents equal to each other. X minus 1 over 3 equals 1. Multiply both sides by 3 and then add the 1. We get x over 4. Now, you try this one. What is the value of x if the side length of terrarium A is 4 times the side length of terrarium B? Pause the presentation, figure out the answer, and then resume. The answer is x equals 7. What? Where'd that come from? Well, if we set up the proportion like we did in the first problem, this time the proportion is 4. And then we continue, take a power to a power, subtract the exponents. 4 can be written as 2 to the second. So now we can set the exponents equal to each other, multiply both sides by 3, and then add 1. And that gives us x equals 7. And that concludes our presentation on topic 1.2.